So in this one, which is problem 3, it says the system below has one solution. Solve the system. Write the answers of integers or fraction in lowest terms. Okay, so the first two problems were turn this system into a matrix. The second one said, here's a matrix, do these operations. And the third one says, here's the system, find the solution. Okay, so this is our first one where we are expected to find the solution ourselves. Right? So the first step I'm going to do is I'm going to turn this system into a matrix. Okay, and what I'm going to do is I'm going to notice what are the coefficients of x, y, and z. So with my matrix, with my x's, I have 2, 0, -2, 8, 4, -8, -16, -32, 18, -19, -20, and 20. All I've done so far is just write down those coefficients. Okay. My goal here is to somehow solve for what x, y, and z equals if that's possible. That's my goal. How might I do that? In the previous problem, we found something like we had some number here, 0, 0, 0. Actually, this could be any number as well, and this could be any number. So as long as we have numbers in the diagonal, everything to the left, I'll show you, I'm just claiming this now, but if we have the diagonal there, everything to the left of it, kind of that bottom triangle, I claim that we'll be able to solve for it in that way. I think that's my new goal. So my new goal is to somehow turn this into a 0. I want to turn that bottom one into a 0. And the tool I have to use is this number right here, okay? And it's called the pivot. So that first column, first row number is the one that's going to be able to zero any of the other numbers out. So somehow I can use that 2 to get the other -2 to go to 0. So I need to think of some arithmetic step that I could do to turn it to 0. And for my numbers, they're equal and opposite. I have 2 and -2. So I think if I just added them, whoops, I want that to be row 3. If I simply add these numbers together, this will become a 0. And that is my first task, is to make that become a 0. But there's going to be other implications that happen. When I add these rows together, it's also going to change this value, and this value. That's one of the implications that's going to happen. It's a consequence. But I need it to happen to zero that out to be able to solve the system. So the first row does not change. The second row doesn't change. But the third row will. Okay? So because I want this to go to 0, hopefully the online folks can see where I'm pointing. I'm pointing at the -2. I want the -2 to go to 0. My numbers are equal and opposite, so I'm just going to add them. That's how I came up with row 1 plus row 3 becomes row 3. When I add these, it becomes 0. That was my entire goal. Everything else is a consequence of what happened. So I still need to add this 8 and that -8, and that becomes 0, but that wasn't my goal, it's just what happened. And I have -16 and 18. If I add those together, I get a 2. I have -19 and 20. If I add those together, I get a 1. Okay? I think if my goal is only to solve this system, then I think I only need to triangulate this matrix, and I've done so. So I think I've solved, or I've done what I need to do with the matrices. I can now leave matrix land and start solving. So what this says, remember where these values came from, or what these values correspond to. This is saying that 2 times z equals 1. That's what that's saying. So since that's what it corresponds to, I can say, well, if 2 times z equals 1, z equals 1/2. Okay? So now I have one of the values. I have z equals 1/2. Now looking up at the next equation here, I have 4 times y minus 32d, which I just discovered is 1/2, equals negative 20. Now there, I can solve for y, because I only have one unknown. Okay, so I have 32 over 2, so that gives me 16. So I'm going to do a little bit of arithmetic just to get this thing. Okay. I'll add 16 to both sides. That's 16 minus 20, that gives me a 4. So that's saying that 4 times y equals negative 4. I think the only way that could happen is if y equals negative 1. Y equals negative 1. Okay. Now I have z and y. I need to find x. I can go to the first equation and solve for what x equals. I know that 2 times x plus 8 times y minus 16z equals negative 19. I can solve for that. I need to find some room on the board here. Space can be a hard thing to find sometimes. What color haven't I used? I haven't used this pink. So this is going here, 2x plus 8 times y, which I just discovered is negative 1, plus 16z, which I discovered was 1/2, equals negative 19. So if I solve this, I can solve for x, and then I've solved for the entire system. But I have to do a little bit of arithmetic to get there.
Wait,
So
I'm
that,
sorry to
yeah,
interrupt.
go ahead.
Did you mean negative? Wait, you got negative 16, but it says 18Z. Am I pulling that from the wrong row?
Uh, I don't know. Maybe I'm messing up. I
I
have
don't
two. I
think
have
so.
2x8y negative 16 equals.
Okay, yeah. I pulled it from the wrong row. I'm sorry.
Uh oh, you were looking at this.
Yeah, I'm so sorry. I'm writing it down too. I looked up and I was like, oh,
I
sorry.
believe you could use that. We don't usually do it, but I'm 90% sure that would give us the same answer. No, I'm 99.9%. I'm 100% positive same answer. So go ahead and use that. I'm not going to, because what we usually do is we work our way back up the ladder, but you'll get the same answer. Minus 8, and then that's going to give me another 8 equals negative 19. So that's saying that 2x minus 16 equals negative 19. And that says 16 minus 19 is equal to 2x. And that gives me a negative 3, and x equals negative 3/2. Okay, so we did use a matrix to help us, but because we're solving for x, y, and z, we got out as soon as we could. Okay, and we went back to just equations. This is the common way to do it, but it's not the only way to do it. Another way to do it is just to stay in matrices until the end. You can do that as well. We'll see some examples later. I'll show you examples later where we do that, but you don't have to. So I would like to teach you both ways, and then you'll get to choose which way you like. And then I'll also show you how we could do this in a calculator as well. But that's at least a good example to get you going for that kind of thing. Okay.